All right, let's continue with chapter 7. We did the first lesson yesterday, and now we're doing the second one. So yesterday we found the area of several different things. What did we find the area of yesterday? What was the first thing we found the area of yesterday? It was pretty basic. Yeah, rectangle. Then we did a square. Then we did a, what else? Yeah, before we did a triangle, we did a parallelogram, and then we did a triangle, okay? So now we're going to find some other, what? Quadrilaterals. Now, yesterday we didn't do all quadrilaterals. The triangle was definitely not a quadrilateral. But today we're going to do all quadrilaterals. And just taking a look what we're doing. Okay. All right. So the first one is trapezoid. Now, to do area, you have to know some formulas. All right. You got to memorize these things. I am not going to put them like as a word bank or something like that on your test or quiz. You have to know what these formulas are. So let's review. What's the area of a rectangle? I'll put R for rectangle. Base times height. Let's use words instead of just letters, okay? Base times height. All right, very good. So what was the area of a parallelogram? It's also the base times height. What was the area of a square? That's right. You could go base times height, or you could say it's sides squared. All right? Either way. Remember we did that little square, the 3 and the 3, right? You could just look at it as base times height and go 3 times 3, or you could look at it as, well, one of the sides is 3. I take 3 and I square it, and I still get 9. All right. So that was pretty easy. Look, the first 3 were all the same. That triangle, I'll put TRI because we're going to do a trapezoid in a minute, so I'm not just going to put T. So the area of a triangle, it's very, very similar to the area of these right here, except for one thing. What do? The triangle is half, okay, of the rectangle. Remember we did that? All right, so the area of a triangle is just base times height, but you got to divide it by 2. Here's another way that you could say it as well. Do you remember how we said that? You could take 1/2 times base times height. Either way, it's the same thing, all right? It just means the same thing, however you want to approach it. So that's what we've done so far. You got to have those memorized. There's no way around it. Everybody understand that? So you got to make sure that you know every one of these formulas. I mean, that wasn't too hard because all these were exactly the same. This one was slightly different. You just had to divide it by 2. Now, the next ones we're going to do take a little bit of extra studying, all right, to make sure that you understand how to find the area of these other ones. So make sure you write them down. Maybe even keep a list. You know how I just listed those 4 right there? Maybe keep a list of all the areas so that you can just go back to it in your notes on one page and just look at those areas. Ben, I'll take that. You can get it from Mr. Osborne at the end of the day. Okay? All right, so let's do, what did I say we're going to do? Starts with a T. Trapezoid. Okay? So the area of a trapezoid. Well, let's draw a trapezoid first. And let's see what's going on here. Let me do this. I'll try to make it look like the example in the book. So that kind of slants like this. This goes about like that. And then this goes to here. There we go. There's a nice trapezoid. Just a little review. What do we know about a trapezoid? It's got exactly one pair of sides that are what? Okay, not equal. Parallel to each other. Okay, so that's a trapezoid right there. It's got exactly one pair of, it's a quadrilateral that has exactly one pair of parallel sides. All right. I'm not going to go through how we got this equation. I'm just going to show you what it is, okay? But we're going to talk about a couple things first. This right here is considered to be a base, and this right here is also considered to be a base. I'm going to call one of them base 1, and I'm going to call the other one base 2. Because if I just called them B, that would mean that they're the same number, right? Do you think the length of this one is the same as the length of this one? No. All right, so I got to make a distinction. So I'll call this base 1, I'll call this base 2. Everybody with me okay on that? All right. Where do you think the height is? Remember what has to be true about the base and the height. You could go from anywhere on the top. Let's go from that corner right there. And then how far, or give me a good word. Give me a good geometry word. Yeah, that's good. That perpendicular. That's what I'm looking for. Good. All right. So it's got to be perpendicular. Zion, you're right. It does make a right angle, but I'm looking for perpendicular. Okay. So what would I call that red one? If these are my bases and this is perpendicular, and it's perpendicular to both bases. Do you see that? Because now I got two bases. How many bases did I have when it was a triangle? I only had the one base, didn't I? Okay. So this, I got two bases here. That's going to make a difference. And then this is my what? My height. Okay. Now, the area of the trapezoid is pretty close, not exactly, but pretty close to the area of a triangle. And I remember, well, triangle is a T, trapezoid is a T, so they have a little bit of relationship. Remember what the area of a triangle is? We just did that a couple minutes ago. It's the base times height, what? Divided by 2, or it's 1/2 the what? The base times the height. But this time, how many bases do I have here? I got two bases, don't I? All right? I don't just have one. So instead of 1/2 the base times the height, what do you think I might do with both of these bases? I'm going to add them up. Okay? Do you see that? So it's very, very similar to the area of a triangle. You just got to remember, they both start with T, trapezoid, triangle. All right? So it's 1/2 the sum of the bases times the what? Times the height. And that's all you do. It's actually not that hard. So how do I find the area? First of all, I got to add up the two bases. And then I take that number, right, multiply it by the height. And then after that, what's the last thing I do? Divided by 2. Just take half of it. It's pretty simple, isn't it? Yeah, absolutely. All right. I'm just going to put some numbers in. I'm not going to use the numbers they use in the next example. I already got the picture here. I don't know. Give me a good 4. Okay. Now, if that's 4, what do you think this base right here is? Yeah, that's probably a good guess. I'd probably say around 7 maybe. Okay. Let's just make up something for the height. What do you think the height is? 3. All right. That's good. That looks like it could be 3. All right, so here's all the information. What do you think they're going to ask you to find? The area. Okay, so let's do it. The area is 1/2 the two bases added up. So I'm going to put it in here. I mean, you could add them in your head if you wanted to, but I'm going to show what it is. Okay? Everybody with me? All right, so 4 plus 7 times the height. What's the height? It's 3. So that's multiplied by 3. So what do you think I'm going to do right now? What's the easiest thing to do so far? Add the 4 and the 7. Good. So what's 4 and 7? 11. And then times 3. So you could go half of 11, or you could go 11 times 3. Doesn't matter which ones you multiply. Okay? So it's half of 33. Half of 33. Which is like 16.5, isn't it? 16.5 if you want to put it in the calculator, right? And let's say it's in inches. These are all in inches, so what's this? Inches what? Squared. Okay? And there you go. You just found the area of that whole entire trapezoid. Again, it's very, very similar to a triangle. But you got two bases. So what do you do with those two bases? Just add them up. And that's all you got to remember about a trapezoid. Everybody understand that? It's kind of easy in comparison to some other things, all right, because it's very close to a triangle. If you know that it's 1/2 the base times the height on a triangle, it's kind of like 1/2 the base times the height on a trapezoid, except you got two bases. And so what do you do with those two bases? You add them up. We good? Yeah, that's not too bad. All right, so that's a trapezoid. What's another quadrilateral that we talked about earlier in the last chapter? A rhombus. Okay, that's good. That's actually after the next one. What's another quadrilateral? A kite. Yeah, it doesn't really matter what order we do this in, but I'll do it in the order that I got my notes in. So now we're going to find the area of a kite. So let's draw a kite. It's not fly a kite, but let's draw a kite. Remember, it's kind of easy to draw a kite if you put these. I don't know if you remember these names. This would be like the axis of symmetry. This would be the crossbar. Do you remember those names? It's really not that super important, but those lines are super important because they are diagonals of a kite. See that one going across and one going up and down? They're diagonals, right? Because they go from one corner to another, one corner to another. All right? So this is really important. So I tell you what, let's change the colors of these just so I can refer to them. We'll make that one red, and we'll make this one, I'll just go blue. Red, white, and blue. Patriotic kite. Okay? So what I want to do is the red one, I'm going to give it a name. Now it's a diagonal, right? And there's two diagonals. You know how we did with the two bases? We made B1 and B2. So what do you think we're going to call the red diagonal? Call it D what? 1, right? What is D1? D1 is that whole entire red one. It's not here to the middle, okay? It's that whole entire red one. Everybody with me on that? What do you think we're going to call that blue diagonal? D2. Good. And again, it's all the way from here to here. It's not where it connects or anything. It's the whole entire diagonal. All right. That's not too hard to understand. Do you agree? Now, again, I'm not going to go through and show you why this is what it is. I'm just going to show you the formula. All right. I could. I think in my honors class, I do go through and show why this, actually, just don't put K. Let's put area. Area, and I'll put K for kite. Is that all right? Equals, and here it is. It starts off like a triangle. How did we always start that triangle off, and how did we start the trapezoid off? With a what? With a 1/2. So we're going to put 1/2. But now, I got no base and height on this. I mean, that is perpendicular. That is true. But what I'm going to do is take those two diagonals and just multiply them together. So if I take D1 times D2, that is the area of a kite. If they give you the diagonals, okay? You got to know the diagonals. That's it. Pretty easy, isn't it? You just have to remember it, though. It's not hard to remember, but it's something you got to remember. Okay? You've probably never seen that before, I would guess. Area of a kite. All right? This is probably the first time that they introduce this to you. So it's 1/2 D1 D2. So what if they told you? Yes, it's the same thing. Yeah, if you wanted, watch. If you wanted to write it like this, D1 D2 over 2, that's fine. It's the same thing, isn't it? All right, 1/2 of this or this divided by 2, it's the same exact thing. If you like that better, feel free. It's no problem. All right, let's put some numbers in here. On this example, they break it down into little parts. So they say from here to here is 30, and then from here to here is 13. See what I'm doing? They didn't give you the whole entire diagonal. They gave you just this little part of the diagonal and this little part of the diagonal. All right? So let me get rid of this. Get rid of this. And they also tell you, oh, they really make this a little bit trickier. This is now this is 115 millimeters, and this was 30 centimeters. This is where they make it a little bit trickier for you. By the way, do you remember on a kite, this crossbar was split in half, wasn't it? So if they just tell you one of these, 115, what's this little bit from here to here? It's also 115. 115 what, though? Millimeters. Do you know the difference between millimeters and centimeters? Let me show you. I'm going to put the mic down for a second. I just got this today from Mr. Cheadle. This is, what would you say this is? What kind of stick? most people would say it's a yardstick, but it's actually not a yardstick. What's a yardstick go to? How many inches does a yard go to? 60? 60 inches is a yard? How many feet are in a yard? Come on, guys, you're killing me. How many feet in a yard? What is it? There's 3 feet in a yard. Let me try one more, okay? How many inches in a foot? You got to know that one. 12, thank you. 12 inches in a foot. All right, so if there's 12 inches in 1 foot and there's 3 feet in 1 yard, how many inches are in a yard? 36, very good. 12 times 3, okay? But somebody look at this, all right? Craig, you wait. How many inches are in this thing? Look at it. 39 and something, okay? 39 and a little bit. So, is this a yardstick? No, it's not. It's not a yardstick. What do you think it is? It's a meter. This is a meter, okay? In America, we're slowly getting into meters and stuff like that, right? If you watch the Olympics, are any of the races in feet or yards? No. Okay, it's usually the 100 what? Meter. Okay, so it used to be, back when I was a kid, it used to be the 100-yard. They used to call it the dash, the 100-yard dash. Okay, but it's not that anymore. Okay, it's the 100 what? Meters. So is that the same exact distance? No, this is, watch, up to here. That's 36. That's 3 feet right there, 36 inches. So that little bit right there, approximately 3 inches and a little bit extra, all right? So a meter is about 3 and a little bit inches longer than a yard. Everybody got that? All right, so that's a meter. So what I'm concerned about is millimeters and centimeters. Let's take a look at this. This whole thing is a meter. How many centimeters sent up in a meter? What is it? It's 100. Very good. Right? It's 100 centimeters in a meter. Has anybody heard that before? Because centa, C-E-N-T. How many cents are in a dollar? 100. So centimeter, there's 100 what? Centimeters in 1 meter. Okay? Here they are. You see the numbers? 1, 2, 3, 4, 5, 6, 7. They make the numbers 10, 20, 30, 40 bigger. But the 1, 2, 3, 4, 5, okay? And you go all the way up to what? There's 90, there's 99. You don't see the 100, but at the very end, it's 100. All right, so there are 100 centimeters in a meter. What about millimeters? What's the difference between millimeters and centimeters? So a centimeter is that little bit about that wide right there, okay? A millimeter is way smaller. How many millimeters does it take to get a centimeter? Give me crazy numbers. That's not metric. Metric, everything's in tens. Okay, there's no 36, there's no 72. Everything's in tens. So how many millimeters? Look at that. Okay. See, that's 1 centimeter. Now, what do you think? Any guesses? Milli means 1,000. Centa means 100. Okay. So how many millimeters? How many? There's 10. Okay. Remember, metric, everything's by powers of 10. I don't know why Americans don't like that, but it's way easier when you agree everything in tens, right? Because look, 12 inches in a foot, 3 feet in a yard. That's crazy. I think it's 1,760 yards in a mile. There's 5,280 feet in a mile. Those are dumb numbers to have to memorize. Wouldn't you agree? Think of a metric. There's 10 millimeters in 1 centimeter. There's 1 centimeter. They call it a decimeter, but nobody uses decimeters. But there's 100 centimeters in a meter. There's how many meters in a kilometer or a kilometer? We usually say kilometer. How many meters in a kilometer? What's kilo? Nobody? Means 1,000. Means 1,000. Okay? So it means there's 1,000 of these in 1 kilometer. You've heard of kilometers before, haven't you? Yeah. Okay? So anyway, that's what we're doing. Let's go back to this. Give you a little metric lesson there. So watch this. I could change this into, let's write this in white. That's what I'm going to do. Exactly right. I do have to convert it. So I've got 115 millimeters. I want to change that to centimeters. It's a power of 10. What do we do with decimals when it's power of 10? We just move the decimal one place. All right? It's so much easier than using the English system. So I got 115 millimeters. How many centimeters is that going to be? Here's my decimal. It's 11.5, exactly right. You see that? I just move it one decimal place. So there's 11.5 centimeters, and they equal each other, okay? 11.5 centimeters is the same thing as 115 millimeters. You guys watching? Okay. So instead of writing 115, what's a better way to write it? 11.5. And we're going to write this, 11.5. And that's in what? Centimeters. Because if I'm going to multiply these together, they have to have the same units. All right? You can't multiply things if you have different units. This is in centimeters. This was in millimeters. But what did I do? I changed it. Okay? I changed it into centimeters. So let's do the math. Area equals what? 1/2 times the one diagonal times the other diagonal. Let's do the blue diagonal. What's the whole entire blue diagonal in your head? What is it? 43. Good. 43. From here to here is 13. From there to there is 30. I add them up. The whole diagonal is 43. That's the blue one right there. What about the red one? It's 11.5, 11.5. How can you do that in your head? 11 plus 11 is 22. 1/2 and 1/2 is 1. 22 and 1 is 23. And you do all that. I'll let you work that out yourself. You can use a calculator. And you get that. Now, what are my units in? I changed everything to centimeters, so this is centimeters squared. Okay. I went way too long on that metric thing. So I got to do a rhombus. We'll do that super quick. And the nice thing about the area of a rhombus, and it's super nice, it's the same. I'll put the word rhombus. Okay? So the area of a rhombus is equal to the same thing as the area of a kite. Isn't that nice? So what's the area of a rhombus then? 1/2 D1, not plus, times D2. All right? And that makes it nice. We got a lot of repeats in here, right? We got the area of a rectangle, area of a square, area of a parallelogram. They're all the same. Triangle and trapezoid have some similarities, right? And then kite and rhombus are exactly the same. So if I had a rhombus, you would do the same exact thing. All right? I'm running out of time. I don't know if I have enough time to do this. I'll tell you what. I'm just going to, I'll do what I did before. Since I know I got to go through that metric a lot faster, I won't waste as much time on that in the next class. So you need to watch the next example. It's example 3. All right? You're not just finding the area. They actually give you the area, and you got to find something else. Okay? I'm going to do that in the next class. So make sure you go and you watch the video. You don't have to watch the whole entire video. Just fast forward to the end. Okay? When I do example 3, all right, watch that. Who's going to do that? Anybody? All right. You need to. All right? You need to do that because you might have a question like that on a quiz and a test. All right? So make sure you look at that. So here's your homework. Your homework is section 7.2. And it's pages 308 and 309. And it's 1 to 14. Actually, I lied. It's 1 to 7. I got to change that on my notes Here's what it is on the lesson plan. And it's better for you, okay? All right, so I skip a few in between. So I skip 8, 9, and 10. All right, so 1 to 7, 11 to 14, that's your homework. But you got to watch the video from the other class and watch example 3, because you might see some of that on this homework. You should be able to do most of them, okay, without that example. But make sure you watch that before you do the homework. All right.